Hi, welcome to the NEDSI workshop for an Ocean 97 and Green Reef Foundation Aquaculture Digital Twin Adoption Experience for HBCUs, historically black colleges and universities, in aquaculture with a net zero waste activity focus. I'm Christopher Tate, and I want to show you this experience. We're going to do this as a video so that we don't have problems with Wi-Fi during the conference. So we have prepared a Red Hat demo platform experience for Smart Aquaculture that we're presenting at NEDSI conference now and the Red Hat Summit in Boston in May. And this is the demo platform, this LB2221 Smart Aquaculture Edge to Cloud Developer Workshop. So it's easy to provision. You click order and you can choose how many users will be participating in the demo. So we click brand event for the activity because we're going to be presenting this at Summit 2025, and we can increase the number of users. For the NEDSI conference, we deployed 20 users. So let me show you the OpenShift environment here. I'm going to go to the console and log in with admin. I have the admin credentials here. I log in and let's take a look around. This is Red Hat OpenShift. It's the cloud platform of choice for open source developers. And if I click on pods and I go to Workbench, let me zoom in so that you can see. We have users 1 through 20 available here. So I'm going to user 1, and we have already deployed the environment, and it's running here as VS Code. So now I will go to networking, routes, and open up this VS Code workbench for user 1. And I'm also going to go to showroom, user 1, and open up the showroom. So this is the lab, an introduction to the Computate and Smart Aquaculture use case. We're going to discuss an overview. We're going to review what is Fireware, and we're going to talk about the use case, what is the Smart Aquaculture use case, modern developer cloud workbenches. So let's dive in. So the Smart Aquaculture use case began when Professor Dwayne Branch here reached out to me to learn the latest developments in open source for IoT and secure data standards. He shared with me some research about smart aquaculture solutions for sustainable fisheries, and I was intrigued. I did some research as well and determined that Fireware has already been working on open source smart aquaculture solutions. I was already working with Fireware smart IoT solutions on Red Hat OpenShift, so I put together the smart aquaculture use case. Fireware is a nonprofit organization headquartered in Berlin. They have a mission for building an open, sustainable ecosystem around public, royalty-free, and implementation-driven software platform standards to the development of smart solutions in multiple sectors, following a digital twin approach. 2022, I heard about the Red Hat Social Innovation Program, started an innovative engagement with Fireware to harness the power of open source technologies to solve global problems. I helped start the conversations with Fireware and also the Red Hat Social Innovation Program as the social innovation architect. I also started a related research project with Boston University and the Red Hat Collaboratory with Boston University. and Smart in Veberöd, Sweden. I also attended the 2022 FIWARE Global Summit in Gran Canaria, Spain, and presented about our FIWARE Innovation Hub on the way at Boston University. Because of the open source value for FIWARE provided for building smart solutions, I started a FIWARE iHub between Red Hat and Boston University. In 2024, the FIWARE community reached out to me and other iHubs to start some discussions about community building related to standards for IoT smart device computing. The target domains included smart cities, smart ports, and smart agriculture. The focus was on how the FIWARE community, including the FIWARE iHubs, can help. I was asked to prepare a panel discussion with 4 other FIWARE iHubs at the upcoming FIWARE Global Summit. This would enhance community cooperation, contribution, and participation with FIWARE's approach to think global, act local. In addition to preparing for this upcoming panel discussion, I decided to focus on developing some new tools within my Computate platform to support FIWARE use cases of smart data models. I also developed a free course that runs on Red Hat OpenShift Developer Sandbox. I was also building the Computate Smart Website Builder that allows software developers to build a custom data-driven website powered by FIWARE. I wanted to put together a complete solution for the FIWARE community to deploy FIWARE microservices to the very best enterprise open source cloud environment, create smart data models, register entities with the FIWARE context broker, and visualize their data in a Computate platform. So the Smart Aquaculture use case is about building your own secure IoT smart platform for sustainable fisheries with generative AI, zero trust access control, and interactive dashboards. It uses modern developer tools to access your VS Code developer workbench in the browser. Doesn't matter your laptop's operating system, Ansible automation automates the tedious tasks of generating all of the boilerplate code for your Smart Aquaculture site. And you can customize it along the way. Developers learn how to build reactive, asynchronous Java code, open APIs, database scripts, and Smart Aquaculture data. Users can visualize the smart aquaculture data in an event-driven interactive dashboards and maps. Platform integrates with modern microservices in the cloud, like PostgreSQL database for transactional data storage, Apache Zookeeper Cluster Manager for event bus messaging, Apache Solr Search Engine for auto-suggest and searchable APIs, Keycloak Single Sign-On for fine-grained access control to smart aquaculture data, FIWARE Context Broker for open source IoT edge device standards. And what is the smart aquaculture use case? We covered these in the slides. So let's get started. To begin working on a use case like smart aquaculture, you need to be working in a supported environment. This Red Hat OpenShift demo environment is all ready to go with all the dependencies and source code to get started. Thanks to the powerful cloud developer tools built into Red Hat OpenShift Container Platform, developers can log into a VS Code workbench directly in the browser and start developing a smart aquaculture platform. The OpenShift AI workbenches provided by Red Hat allow developers to write code in the browser. It doesn't matter what your computer architecture or operating system is. And the sovereign generative AI behind Smart Aquaculture Platform, because developing microservices is hard and requires a lot of tedious configuration of databases, open API specs, and code, it really helps to write down your ideas in a logical way and have the code generated for you. This is how the Computate software powering the Smart Aquaculture Platform works. You define a logical list of variables to decide how your platform will be customized for your organization and your use case. Then the boilerplate code that you need is automatically generated for you to jumpstart your project. Then you work on building specific models for your specific use case. Then you can create articles that explain your project. A modern a model in a platform powered by Computate is generally, okay, we're going to get to that. Let me jump to the AI workbench. So the OpenShift console is the visual web-based way of interacting with your cloud deployments. We're going to log into the OpenShift console with this password. So click, let's see. Here we go. I'm going to log out and log in as user 1. So here we are. I'm going to log into Red Hat OpenShift AI. I'm going to log out, log in as user 1. Go to data science projects, go to my workbench, workbenches, VS Code, open this workbench, log in as user 1. I'm going to click allow selected permissions. I'm going to click yes, I trust the authors. So this has all the source code we need: the Computate code generation project, Computate base, Computate search for search engine tools, Computate Vertex for reactive asynchronous coding in Java, and Ansible playbooks, a Python virtual environment, Ansible roles, and the Smart Aquaculture project, which only contains variables at this point. We have variables for OpenShift, which is our cloud environment. And this doesn't contain any passwords. This just contains lookups to environment variables and other secrets instead of containing passwords, so that we don't have any problems with secrets management and exposing secrets. We have site variables for our Smart Aquaculture site. We have a mailing list for questions. We're going to generate an open API spec. Here's a bunch of Java configuration details of where our code is. And Vertex is the scalable aspect to this. It's the scalable, Vertex is the Java reactive asynchronous scalable framework that allows us to get really good performance out of our application. Now it says, do you want to install the recommended extensions, VS Code Java and Red Hat from this repository? I click install, and it's going to automatically install these extensions that we need. And then we have open source license information, container information, because we're going to turn this into a container, or we already have in the project. We have static content details about our web component framework that we use, and our icons that we use in the site, and our theme. And we're not populating the developer details, but that's useful when publishing to Maven. We're not using the systemd service for this because we're doing this in the cloud. It's powered, what it's powered by. Zookeeper is our cluster manager for managing requests. Apache Solr is our search engine. PostgreSQL is our database. Keycloak is our authorization and authentication service. Spyware variables for managing smart data models and NGS-ILD context broker data. We have message broker configurations here that are possible. Kafka, MQTT, AMQP, RabbitMQ, how we're going to deploy this and how much memory and CPU, and other features that we enable. So this is all good to go. We got our extensions. So I'm going to start by creating a bunch of scaffolding code. So this is a Jupyter Notebook, and when opening this Jupyter Notebook in VS Code, we select a kernel. We choose Jupyter kernel bash, and then we can run these as Linux bash commands. So I run this, and it shows us our vars. And now there's no longer any lookups. It actually looked them up and printed out the actual values to these variables. So that's useful. Now we're going to generate code. So besides our vars that are in this Smart Aquaculture project, now we're going to create a launch.json. So this is here. This is the launch configuration to launch Smart Aquaculture and also to rebuild the Smart Aquaculture API. And then we're going to create a getignore file. So this gets created in the Smart Aquaculture project here, right there. Let's see. And then we create a pom.xml, which is the Java dependencies for the project. Now there's a pom.xml, and then we create a config keys.java, which is for configuring public static final strings related to environment variables for the site. So that goes in here, config keys, and we create a site request.java. And a base result.java for storing data in the search engine, but not persistent in the database. We create a base model.java for storing data in the database. So these are found here, request. We have these files now. We're going to create a package info, which is for Vertex Service Proxy API code generation, since we do a lot of code generation. We create a project site.css. So this is going to create a new directory in here called Smart Aquaculture Static with a site.cascading style sheet for website style. And we create a site.js for some basic JavaScript required for the site, and a site module.js, an additional JavaScript module in the site that makes the page appear after all the web components have finished loading, a leaflet.contextmenu.css for CSS style for menus inside of maps, and leaflet.contextmenu.js JavaScript for menus inside of maps, leaflet.draw.js for drawing polygons and points on a map, as well as the CSS for leaflet draw. Leaflet.js for creating maps and graphs on the site, and the CSS for leaflet. And the leaflet sprite sheet.svg for icons on the site, marker icon.png for a little marker symbol when you click a point on a map, and sock.js. This is for WebSockets in the site for event-driven messages from the server back to the connected browsers to the updated page based on data changes. Sock.js map.json is related to that. And Plotly 290 min.js for graphing things on the site, and Vertex Event Box is also related to WebSockets and event-driven messaging. And some logos for Computate and logos for OpenShift and logos for Smart Aquaculture, both the dark theme logo and the light theme logo, so that we can switch themes, light or dark. And these are files related to code generation and indexing source code in a search engine, because we're doing AI by parsing all of our Java code and indexing it in a search engine. This lets us have intelligent code generation that knows about your project and can add the right dependencies and relationships to your code based on what it finds in its search engine model collection of code. So we create all of these scripts. Now we're going to create a container file or Docker file. You might be familiar with Docker containers, but this is for building our Smart Aquaculture site into a container. We create a page layout.java for handling pages in a consistent way. And we create a homepage.html file. So that was a lot of clicking, but we made it through. Next, we're going to run some Computate AI code watcher stuff. So this is actually going to generate a bunch more code here. So there's some Java code that needs to be generated for code to compile correctly. We use the Computate project to generate the missing code. So this is going to index all of the Java code that it finds into the search engine. So if we go to solar.apps. Oops. Okay. We go to log out. Log in as admin. Oops. Here and refresh. Log in one more time. Networking routes. Solar. Create a route. Solar. E983 is the port. TLS termination, edge, redirect, insecure traffic, and create. Now we can access this and we can check out the Solar admin password here. Copy this to the clipboard. Admin, password, collection, Computate user 1, query, execute query. There's 2,552 already known Java classes, Java methods, Java fields, and Java constructors that it found in the code in our project, and it stores all the data in an internationalized language sort of way so that we can get to that, get information about our code. So that's what's happening here. I'm going to continue, and we're going to use this command to watch our code for changes. So if I open a new terminal, I can paste this command here, watch now, and it's going to wait to detect any code changes. So it's ready and watching. Now we're going to generate some more AI templated files based on what it finds in the search engine. So we create sitepage.java first. And what we should see here is it's watching for code changes, and we should see it. So it printed some stuff out. It says class site user missing. So that's this one right here. So we're going to create the site user.java. So it generated the site page. Whoops. Okay, next, I'm going to pull up site user.java, which is a newly created file, and we're going to just touch this file, and it should recognize that something changed here. Okay, so now it saw that site user was touched, but it had a little error. So it's going to work through and generate some code here. So right here is site user.java, but we should see some code appear next to these. Here's the code. So it just generated all of this code for us, which is really nice because it's a lot of code. Actually, it's still in the process of writing it, I think. So site page.java. Close these extensions, close others. Site page.java. I'm going to resave this. And we're going to resave this. Go back to run Computate AI Code Watcher. Let's see, go to this one, generate AI template files. Okay, continuing on. Now we generate the site routes. We generate the worker vertical. So the code generation looks happier now. Now that it's figured out, now that it has a site user file, which everything depends on, and we're going to create the main vertical. So these files are found worker vertical. Worker vertical is for background processes. And the main vertical is how the site starts. This has a Java main method where everything begins when the site runs. So we've generated a bunch of code, and for the next steps, we're going to generate an open API spec. So it says run this code in a new terminal. So I'm going to copy this, create a new terminal, and paste this here. Site user. So you can see here that it registered two APIs, the two that we generated, which were site page, which is for articles in the site, and site user. It does work to create authorizations for these APIs if that's required, or if it's public data, then the authorizations aren't required, but we register things with KeyCloak, our authentication provider, and we configure the APIs here. So we do authorization, and we also register the APIs in an open API spec. So this is downloading all the dependencies for Smart Aquaculture before it builds the source code. So what it's generated here is config keys, which extends another class called config keys that has a whole bunch of variables and Java code to initialize variables with Jinja template syntax and initialize page context information, and then let's see, so we have a base model. Let's see. Okay, so this is done. We've compiled our site. So next step is to rebuild the Smart Aquaculture API. So this is going to run, and we click fix because it doesn't know about these dependencies yet. So let's try running this. Actually, what the instructions say is, let's see, where are we at? We're on this one, regenerate API. So it says that we should refresh. So I'm going to refresh this workbench, and we're going to wait for the Java dependencies to reload. Okay, I think it's ready. And then we come over here to run and debug. We choose Rebuild Smart Aquaculture API. And it went and created an Open API spec, which is Open API 3. This is the Open API spec. If I take this in editor.swagger.io, then I can paste this in here. And here's our Smart Aquaculture API so far with articles, site users, and some default stuff to log out and do a OpenID connect callback. Then come back here, and it also created a table for site users in the database and added all of these columns for the site user, and it wrote some fireware context. We won't go too much into that right now. But if I run this site now, let's run this. So here's a link to the running site. Configure trusted domains, tell it to trust this site. Okay, let's go down, see what it said here. Oh, okay. Couldn't find page resources, Smart Aquaculture static, WebAwesome, templates, page layout. Maybe we missed something. Page layout.html. Oh, whoops. So let's go back to create scaffolding code. Page. Oops. Oops. What happened to it? Okay. We're going to copy this code and put it over here and create a new code block and run this. Somehow I messed up my playbook here. So if we refresh, then now we actually have a Smart Aquaculture site. So cool. Blank, but let's do some code generation. So we're going to create a model for fish populations. So we create some environment variables related to fish populations. This is the class simple name is fish population, has some language context of fish population for tracking fish population data by location, and an icon. And we generate some more language context here with this next block. And then we create a directory for this. So we go to model, refresh, and there should be a model fireware fish population that's empty. And then we want to see this get generated. So we make the Java class file. And this is what it's going to write. It just writes this much code. But then what's going to happen behind the scenes is it's going to do a bunch of code generation on this. So fireware fish population.java, instead of like 10 lines of code, it's now 447 lines of code because it used AI to generate this fish population model with fish removed and date modified and date created and date provider cultured in, body mass, alternate name, address. So this is a smart data model, which comes from github.com/smart data models. And if you go to Smart Agri-Food and go to aquaculture, it's this fish population model. And this is the model. This is where the data comes from. Address, alternate name, area served, body mass, cultured in. It came from this. And so we used AI to generate this fish population model into our site. So what we need to do here to finish this off is rebuild the OpenAPI spec, the database scripts, and more. So we run this. And what's going to happen is it's going to create a new table in the database for fish population and add all the fields, and it's going to update our OpenAPI specs. So if we go to OpenAPI 3.enus and we select all of this text and put it into Swagger editor, then now there's fish populations APIs, and it built all of these for us: get, patch, post, delete, put, by an entity short ID. Pretty powerful. So then we come back here. Let's see. I'm getting lost. I'm gonna close some tabs. I'm gonna move this down there. Okay, we're going to update the main vertical to register the new API in the main vertical Java. So we search for fish population and we configure the API for fish population here. So it rewrote our main vertical for us with AI and added all the imports that we need and does the authorization of data for fish populations here based on an admin role and a super admin role and a fish population editor role and a fish population viewer role. And then we can continue on here, generate the worker vertical, and update the page layout. And now we just compile the Java project. And so it looks like it's complete, build success. So then we come back here and now we've already regenerated the API. So let's stop this and start this again. Now we got to fix because it doesn't know about the updated code. So we're going to refresh VS Code so that it knows about the changes and run this again. Okay, so come back over here, refresh the page. And now we have fish populations in our site. So we can click on this and log in as user 1, log in, allow, Now we got to put in some details here. user1@example.com, user last name 1, submit. This is just a demo. Okay, so it says no fish population found, but it doesn't let me create anything. Why is that? I need to go to Keycloak, our identity provider, to do that next step. So I go Keycloak, apps, and authenticate here. Let's see, I need to grab the password real quick. So I go to Keycloak. Okay, I think we're in. All right, we're in. And I change realms to Smart Aquaculture, go to users. Sometimes this version of Keycloak has some UI bugs, but it knows about these two users. So I'm gonna refresh, and I can add user 1 to some groups. So I join groups like fish population editor, join. And then if I refresh the page, now I can create a fish population. So I create, and I give this fish population name Louisiana, and create it. And there we go. We have a fish population, and this is Louisiana over here. It just guessed where it should go, but I'm gonna put the point over here and say set location of fish population Louisiana. And then let's also specify an area here. So we click, say, here's our fish population, set area served of fish population. So we set up an area for our fish population. Let's also give it a description. Fish population in Louisiana. So we've updated the location, the description, and we're using Fireware IoT standards called NGSI ILD. So when we update these values, we also update them here, like the description, fish population in Louisiana, and the NGSI ILD tenant is related to location, and the path is also related to location, so it says /USA here by default. And we got the point on the map, and we got the polygon line string on the map. So we can add as many fields as we want. So body mass, let's say 10, and it'll put that body mass data in here, value 10. This is Fireware context related data. So this is how it works. So it's that easy. We used AI to generate this whole dashboard and API, and we can create more than one fish population. Go back, create fish population, Florida. Here's our Florida fish population, and we can go back to all fish populations and see. Here are our two fish populations out here. Yeah, fish population Florida, fish population Louisiana. There we go. So I hope this was useful. This is our smart aquaculture platform that we're trying to use to create create net zero waste on fisheries and make things more efficient and modern and be able to help with fishing here in the United States and make it sustainable. Thanks for watching.